Welcome to The Explainer. Today, we're going to pull back the curtain on one of the most fundamental parts of your computer, something that's totally invisible but makes everything you do with your files possible. I mean, think about it. It feels instantaneous, doesn't it? Almost like magic. But behind that one simple click, there's this powerful, super organized system doing all the heavy lifting. So yeah, let's dive right in. The hero of our story today? It's the file system. And probably the best way to wrap your head around it is to think of it like a really, really good librarian for all your computer's data. Yeah, just like a librarian, it knows exactly which shelf, which row, which spot every single piece of information is stored, so you don't have to worry about it. I mean, without a file system, your hard drive would just be this chaotic, totally useless warehouse of data. You'd never find a thing. So this digital librarian is basically juggling three huge jobs all at once. First, it has to figure out where to physically stick your files on the disk. Second, it's kind of like a translator. It turns your simple command, like open this document, into super complex hardware instructions. And then finally, it handles everything we see, giving files their names and, deciding who gets permission to open them. Okay, so if the file system is our librarian, then what kind of library is it working in? Because the physical hardware, the shelves, if you will, is just as important. Let's take a look. So your computer basically has two kinds of storage. You've got your primary storage, which is RAM. It's blazing fast, but the moment you turn the power off, poof, it forgets everything. Then you've got your secondary storage. That's your hard drive or your SSD. It's slower, but it holds onto your data forever. And that's the permanent library our file system is in charge of. And that permanent library really comes in two main flavors these days. You have the older hard disk drives, HDDs, and the modern solid-state drives, or SSDs. And the key difference is huge. An SSD is all flash memory, no moving parts. That's why it's silent, way more durable, and so much faster. An HDD, though, that's a different story. It's all mechanical. And to really get why HDDs are so much slower, this is the perfect analogy. It's like a tiny, super fast record player for your data. There are actual physical parts that have to move around to find the exact right spot on a spinning disk. And that slowness really comes down to two big delays. Before a single bit of data can even be read, the drive's little arm has to physically move to the right track. We call that seek time. Then the disk itself has to spin around so the right section is right under that arm. That's rotational latency. All that physical movement is what takes up all the time. All right, so we get the physical space now, the library building and its shelves. But how does our librarian, the file system, actually organize all the books to make things efficient? What are the rules? Well, the first big rule is something called blocking. See, instead of moving data one tiny byte at a time, which would be crazy inefficient, the system moves it in fixed-size chunks called blocks. The shopping cart analogy is perfect here. It's just way faster to move everything in batches. But choosing the right size for that shopping cart is a really tricky balancing act. If you use small blocks, you're great for tiny files. You don't waste a lot of space. But if you use big blocks, you're way faster for huge files like videos. It's this classic trade-off, and it's why most systems today just settle on 4 kilobytes as a pretty good middle ground. Okay, the next clever trick is called buffering. And this one solves a huge problem, the massive speed difference between your lightning-fast CPU and your much slower disk. So a buffer is basically just a temporary waiting area in that fast RAM we talked about. The chef analogy is great. It's like a prep station, making sure the CPU never has to sit around waiting for the disk to catch up. And this is where it gets really smart, with something called double buffering. See, with just one buffer, it's a stop-and-go kind of thing. The CPU waits, then the disk waits. But with 2 buffers, now they can work at the same time. While the CPU is busy with the data in one buffer, the disk is already filling up the second one. It's a simple idea, but it makes a massive difference in performance. Okay, so we've got our data grouped into blocks, and we're moving it around efficiently with buffers. But how does the file system decide where on the disk to actually place all the different blocks that make up one single file? Well, it turns out there are 3 main strategies for doing this. And, you guessed it, each one has its own pros and cons. You can stick all the blocks right next to each other, you can link them together like a chain, or you can use a special index block that works like a table of contents. And the really crucial thing to get here is that there's no one perfect method. Putting all the blocks in a row is super fast, but it wastes space and isn't very flexible. Linking them is flexible, but it's a pain if you need to jump right to the middle of a big file. The indexed method, though, gives you a great balance of speed and flexibility, and that's exactly why it's the foundation for pretty much all modern systems, from Unix to Linux to Mac OS.
Okay, so we've gone deep into the low-level mechanics. But how does all this crazy complexity get presented to us, the users, in a way that actually makes sense? How does the librarian make the card catalog we can all read?
The answer is the directory, or as we all call it, a folder. And here's the cool part. A folder isn't some magical box. It's actually just another file. Its whole job is to be a list, like a phone book that connects the names we understand, like my vacation photos, to the complicated pointers the file system uses internally. And believe me, this system has evolved a lot. The earliest computers had just one giant folder for everything. Can you imagine the chaos? Then they got a little smarter and gave each user their own folder. But the real game changer, the thing we all know and use, was the tree structure. You know, folders inside of folders, inside of folders. It's organized, it's flexible, and it's on every modern OS for a reason. All right, let's pull all these threads together and look at the big picture. So that magic of saving a file, it's really this incredible symphony of different layers all working together. You start with a physical disk, which gets organized into blocks. Those blocks get assigned to your file using one of those allocation methods. And this whole complex mess is presented to you through that simple, clean folder structure, all managed completely seamlessly by our digital librarian, the file system. It's pretty amazing, right? It's the invisible architecture that organizes our entire digital lives. So next time you click Save, maybe you'll think about that librarian working tirelessly behind the scenes. And that wraps up this explainer. Hey, if you enjoyed nerding out with us and demystifying the file system, we'd really appreciate it if you could hit that like button, share this with someone who might find it interesting, and of course, subscribe to Tech Talk 101. We do a lot more deep dives into the tech that powers our world. Thanks so much for watching.